Dr. Postel, let's talk about these ingredients.
Sure.
And we'll see sometimes this right here, shear, lift, instability, and moisture. Give us a quick 101 on these.
Shear, a lot of it can help thunderstorms survive in an otherwise environment where they would fall apart. And it helps organize the updrafts and downdrafts and allows them to last longer sometimes and be more capable of producing tornadoes. So that's one of the things to look at. Lift is often what's required to initiate, to start the thunderstorms going in the first place, because you need something. They don't just spontaneously form. Sometimes they do, but that's very rare. You need something to get them going, to break the cap, so to speak, and the lift can help that. Instability oftentimes is a measure of the strength of the updrafts, and they're more buoyant typically with greater instability measured by way of what's called CAPE, which is called convective available potential energy. So generally the more of that there is, the stronger the updrafts. You can relate the two very easily, and oftentimes associated with more severe weather, the higher that is.
And moisture and instability are very similar, right?
These two go together. There's a significant overlap. If I were to redo this, I would probably just call shear, lift, and instability SLI instead of SLIM.
What is one or two more important than another? So if you take one of those out of the equation, like say tomorrow when we're expecting potentially a big severe day, you take one of those out of the equation, and does it kill the day?
Doesn't necessarily kill the day, but it makes it probably more likely or less likely. If you were to reduce one of these by a significant amount, you would probably reduce your odds of severe weather. They all kind of work together. I would say if any one of them were zero, if you had zero instability, you probably wouldn't have any convection, I'm guessing.
So no thunderstorms. With zero instability, you're probably not going to get thunderstorms.
I'm not sure I see how that could happen. You won't have free convection. You might have forced lift, but I don't think you could get thunderstorms that way, right?
So would you say instability is number one then? Is that the most important that we look at first on a severe weather day?
Maybe so, right? Because if you have, you could have a highly sheared environment and nothing happen at all with no instability. Although those...
There's always exceptions, right?
I'm trying to think because I'm not sure how you could possibly arise in that situation. I mean, how you could come about with that. I was trying to think, I'm going to get tripped up here. I'm wondering if the shear comes about with horizontal temperature gradients, right? So by definition...
So some of them are kind of dependent on each other.
They're kind of dependent on each other. It's a
So
little
you
tricky.
almost can't have one without the other, or you can't not have one and still have the other.
It's tough. The situation would be tough, right?
Okay.
To completely hold one fixed and to vary the other.
Okay.
Hard to see that
They're
happening.
too intertwined.
There's definitely relationships there.
Okay. So which one, like when you're looking for a bad day, like, oh my gosh, it's going to be really bad, which one of those ingredients really stands out to you? Or if you see one high, what's bad?
These two, shear and instability, are very important and are a significant part of a parameter called the significant tornado parameter, which is basically designed to sort of put this all into one number. So you can instead of look at all of them and each one of them individually, it kind of puts it all together and gives you some measure of the risk of tornadoes, significant tornadoes. And both of them are weighted appropriately in that measure. So I would look at two. I would look at shear and instability.
Shear and instability are the biggest ones?
To me, yeah.
Okay.
Yep.
Because lift really gets the process going, right?
It does.
Okay.
It does. And usually it finds a way, right? With a highly sheared environment, you probably have the front nearby, so that will compensate for the lift. In other words, you probably have lift also nearby.
And again, all three to four of these are pretty well interrelated, right?
I would say so.
Okay. Anything else about these?
Well, let's talk about tomorrow.
Okay.
Saturday. So one of the things that is probably limited is the instability. Looking at some of the forecasts for CAPE, not particularly high. Generally underneath 1,000 joules per kilogram mixed layer CAPE.
But you have three that are really high here, right? There's three that are high and one's medium.
High. Right. So
that looks bad just by looking at it.
Yes. Let's do this. Okay. Let's do this. Let's talk about the instability. Okay. So what we've got is definitely will have significant shear. The lift will be associated with any perturbations in the jet stream that move through of the warm sector and or the front that moves in. So we're definitely going to have that. And the instability, medium, I would call it low.
Okay.
I would bring that down probably to the lower end of the scale. Like, for example, on this map right here, this is a forecast. Again, it's a forecast, so it could change. But the idea is that some of these values out in here for CAPE are on the low. Let me see if I can actually, you know what? That's not CAPE. Let me get mixed layer CAPE. Some of the values out here, mid-afternoon tomorrow, are underneath 1,000 joules per kilogram. If you just look at the gray shading here, that's the forecast for the instability. Here's the scale down here. So this is low to high, right? So we're going to be on this end of the scale, likely. Now, that's one model, so there's going to be some error in that, but still.
So when you see that being pretty low on the low end, and it shows you that maybe instability's weighted a little bit more on a severe day, is that fair to say? It's a little bit more important? Well, because if you take away instability, it's going to be hard to get to. I mean, there's so much going on. It's extremely dynamic. It's not this easy, I guess is the main point, right?
Correct. You have to look at a combination of ingredients and then assess it that way. You can't just look at one. That's not going to really get you a lot, I don't think. But there's definitely scatter and correlations between these ingredients and the likelihood of severe weather, including tornadoes in particular.